Okay, so did you have any questions from the preparation homework?
Not particularly. I just felt like it was more, I have to review it, you know?
Yeah.
Did you?
No, it was pretty straightforward. It's just, yeah, it just seemed like a continuation of the last lesson. So I
Okay.
think we can just go straight into the quiz if you want.
Yeah.
Okay. Let's do this.
Okay. Um, use the normal probability applet. Are you there?
Yep, I'm there.
Oh, okay. So use the normal probability applet to find the combined area under the standard normal curve that is the right z-score equaling 1.358 to the left 1.358. Your answer to 3 decimal places. So for that one, I just got 0.087.
0.17. Wait, I'm sorry. So what did you get?
So I got 0.087. So I just put in their z-scores they gave me to find the area.
So I put in 1.358 and I get 0.8255.
Oh my gosh, wait 1 second.
Area.
Oh, you know what? No, that's what I get too. I'm sorry, I didn't highlight the correct area.
So it's to the right of Z.
To the right?
Let's highlight the sides. And with that, I got 0.1745.
0.1745. Yep, that's what I get to for that.
To the right of that and to the left of that.
Yeah.
So that'd be
0.174 or 175, I guess.
Yeah, 175. 0.175. All right. Question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Which will have smaller standard deviation?
Can that be determined?
Let me check. This question was on our last quiz too, and I think I got this one wrong. Let me look back to the last quiz, or the homework quiz. Standard deviation. I'm not sure. Are you sure?
You know, I don't think it does, but you said it's in the homework. I didn't see it in the homework.
In the homework quiz.
Oh, okay. I haven't taken that yet.
Smaller. Let me check the notes real quick.
Okay.
Let's just say it'll be smaller distribution of sample means for now.
Okay.
Okay.
Which of the following results implies that a spread decrease as the sample size increases? So for this one, yeah.
I'm sorry, go ahead.
Isn't that the 695, 97, or 99 rule? Or is it the central limit theorem?
The spread decreases as the sample size increases. What does it mean by spread?
That's what I was trying to remember.
Decreases. Sample size increases.
I think spread is like when we did the 68, 95, 99 rule, like the one standard deviation, the two. Is that maybe not?
Should the following results implies? I'm just trying to understand what the question's trying to ask.
This also was a little bit more difficult.
Yeah.
Like the homework wasn't too bad, but just I don't know.
Yeah. I'm going to say the normal distribution. I'm not sure. We can put different things. It's fine. We'll go back.
I'll put that too, and if not, we can.
Yeah.
Okay.
Use the following information to answer the next 4 questions. Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mean of 150.8 and a standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay, so go back, look at that equation from the notes. So we'll do her score 160 minus the mean of 150.8 divide by standard deviation of 8.8. I got 1.045.
That's what I got as well. But my question is, so don't you remember how z-scores have to be between 0 and 1? Like they can't be. You think that's?
No, that's not the
z-score.
That's not the z-score. Whatever number. The thing that has to be between 0 and 1 is the area under the curve, the probability.
Okay. I gotcha.
You can't have you can't have like negative 10% chance or like 110% chance of something.
Right.
It's got to be between 0 and 1.
Okay. So yep, I put 1.045.
Okay.
The next one, let's see. What is the probability that a randomly selected student will score above a 160 on the quantitative portion of the GRE? So if you put that
in. Yeah, put that into the thing.
I get 1.48.
0.148, yeah. Easy. Okay. Question 8. So a random sample of 5 students was selected to take the GRE. Their scores are blah, blah, blah. What is the z-score corresponding to the sample mean of their student scores? Okay. So
I'm a little bit confused about what that's asking. The z-score corresponding to the sample mean?
Yeah, so you add it up, get 160 plus 175 plus 163 plus 149 plus 153. Take the average, divided by 5. So the average is 160.
Right.
So to find the z-score, you use the equation 160 minus 160. That's going to be 0. So I'd say this
divided by
0. Right?
Wait, yeah, it's 160 divided by 160, and then
160 minus 160 divided by
Right.
8.8. Yeah.
Which is, let's see. So I got 141.81.2.
141.
Yeah.
How did you do that?
So I did the 160 minus 160, which is 0.
Yeah.
And well, I guess it would be 0. I don't know why it's not. Hold on, let's just.
Yeah, it should be 0.
0
Because 0 on top, 0 divided by anything is 0.
is 0. Okay, duh. Let's see. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by students in the previous problem? So
5 randomly selected students. Okay. It should be 0.5.
how do you get that?
So I put in z-score of 0, which puts it in the middle. Anything greater than that is takes up half of the area under the curve, so it'd be a 50% chance of scoring higher than their mean, which was 160.
Okay.
Did we do that wrong? No. I think we're wrong because the z-score is not 0 because the average sample is 150.8, not 160. That was my fault. I'm sorry. I misremembered that number.
Oh, you're fine. Okay, let's redo that problem then.
Yeah. 150.
So it's 160 minus 150.8
Yeah.
divided by 8.8. So that's 1.045.
With this one, do we have to include that there's 5 students?
What do you mean?
Like with the equation that we're given, z-score equals the value minus the mean over a standard deviation.
Right.
Sometimes you use just the standard deviation. Sometimes in the denominator you divide the standard deviation by the square root of the number.
Oh yeah. Oh, you're right. Yep, that's what we need to do. Because it is a random sample of 5 students. Okay. So
Okay. With this, I came up with 2.338.
1 second, let me make sure I get.
Okay.
What did you get?
2.338.
Okay, that I got you.
Okay. You're right. So then, for question 9,
we'll
scoring
just plug
greater
that in.
than that. Sorry, what was that?
Sorry, I'm talking to myself. I'm just saying we should just plug that number in then.
Yeah. So I'm getting a probability of 0.010.
Are you doing greater than?
Yes.
Or let's see, what does it say? Previous problem. That is
Just greater than.
just greater than. So I put in 2.338 into the z-score, and I'm getting 0.009 when I do greater.
0.0. So I've got 0.0097. So I just round
That's what
that.
I have.
Okay, 0.0.
To 8. Okay.
Okay. Is it my turn to read the next question?
I am not sure.
Okay.
I think so.
Let's see. Supposed to the mean GPA of BYU Idaho students is 3.5. and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sample distribution of the random variable? This can be approximately normal.
Yep.
Okay.
Yep. Okay. What is the mean of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population? So
it would just be 3.7, right? It's the same.
I think so. Wait, isn't the mean 3.5, not 3.7?
Was it 3.5?
Yeah, that's what.
Sorry, I'm getting numbers mixed up today. Thank you. All right, we good on that? Do you want to move on to 12?
Yep, that's fine.
Okay. What is the standard deviation of the distribution of the sample means, sampling distribution for all possible samples of size 81 that could be drawn from the parent population? So standard deviation. So it'd be the standard deviation divided by the square root of 81. I'm getting 0.07 repeating. Does that sound right to you?
Let me see. Yeah, that's what I'm getting to. 0.7 repeating. So just
0.077. I would put 0.078.
7.
Yeah.
Yeah.
0.78. Well, that makes me think now if that's the answer to question 12, going back to question 4, I would think that the distribution of the individual observations would have a smaller standard deviation then, right?
You know, you're probably right.
That makes me want to change my answer. Okay.
Well, if we're wrong too, we can just
go
back and correct it.
Okay, question 13.
Okay. What is the probability that the mean GPA of 81 selected BYU Idaho students will be less than 3.3?
Okay, so we have to do z-score, right? Yeah.
I think so.
3.3 minus 3.5. Divide that by the standard deviation, 0.0. I'm getting negative 2.571 for the z-score.
Yeah, I do too.
To
Wait. Hold on. Let's see. Wait, let me actually redo something. Yeah, 0.285 or 286, I guess.
What's that?
Wait, what did you get?
For the z-score or for the probability of it being less?
What'd you get for the z-score?
Negative 2.571. What did you get?
Doing something wrong for 80 selected students. Did you do 3.3 minus 3.5 divided by 0.7?
I didn't do 0.7, I did 0.07 repeating. Because that was the standard deviation that we calculated.
For the, okay.
For this sample from the parent population.
Okay, so now I get 2.86. Okay. Okay, so for the area, I got 0.002.
For my area, I got 0.005. The z-score I got was negative 2.571.
I'll just go with yours then. I think I just switched that up.
I might be wrong.
2.571.
Yeah.
Okay, and then less than, let's see. Okay, that's fine. I'll put that.
All right, question 14. What is the probability that the mean GPA for 81 randomly selected students will be greater than 3.3? So just be 1 minus the previous answer, 9.5.
It would be 1 minus what?
Our previous answer, 0.05. So it's going to be greater than 3.3 with that same z-score, making the area or probability 0.995.
Okay. The United States Coast Guard assumes that the mean weight of passengers commercial boats is 185 pounds. The previous value was lower but raised after a tragic boating accident. The standard deviation of passengers weights is 26.7 pounds. The weights of random samples of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that the random sample of passengers will have a weight that is extreme or more extreme than was observed in the sample. Okay. Extreme or more extreme means that we're not only interested in values that are lower than the ones we observed. But also values that are as far away from the mean as ours in a positive direction. Okay.
All right. I would do 185 minus 177.6, right?
Yes.
Divided by 26.7, which is divided by square root of 48. All that together gives me a z-score of 1.920. Looking at the area, that's both.
And they said greater than? Is that right?
It said greater and less than, right?
Okay. So, yeah, I think so. 0.0549, is that what you get?
Yeah. Okay.
So 0.55. Okay.
Okay, so submitted, we got 15 out of 17. There's just 2 questions we missed.
Which ones did we miss?
Question 4 about the distribution, the smaller standard deviation. We missed question 5 about the spread thing. Those 2 of those confusing questions.
Okay. Let me see. I haven't taken my turn yet, so I'm gonna make sure it's right. The distribution of sample means is the one I'm gonna put.
Okay.
And then for 5, I'm gonna try this. I don't know if it's. I think it might be the central limit theorem actually. So I'm gonna try both those. We'll see.
Okay.
Okay. Okay, so I got one of them right. Hold on, let me see which one I got. So the distribution of sample means is question 4. And the central limit theorem and the normal distribution are wrong for 5.
So maybe it is the 68, 95, 99.71.
Okay.
Spread decreases.
And I'm debating whether or not I even open it back up.
Yeah.
We get a 90. What'd you say?
Attempts do we get on this?
We get 2.
We get 2. Okay.
2 attempts on this? Is that what you asked?
Yeah.
Yeah. I'm retaking it. Just in case.
Okay, so question 5 is actually the law of large numbers.
Oh. Okay.
Weirdly.
Did you already submitted your second turn then?
Yeah.
Oh, okay. Still
Okay.
just finishing up mine. So I guess we'll just okay.
All right, cool. I'll see you next Monday then.
Awesome. Thanks. Bye.